For our first section, we are going to go over rotations and how to find the fraction and the degree that an image would have to rotate to land on itself. So when I have an 8-piece wagon wheel, when I turn it, I'm going to imagine that this wagon wheel has the 8 rims on it, so I'll draw a little picture. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So it has 8. It's an 8-piece wagon wheel. If I turn it, how far would I need to turn it for it to land on itself? So it basically looked like it disappeared. Huh? Yeah, not disappear, but like overlapped. So it looks like it's the same wheel again. So if I turn it, I would only turn it 1/8 of a rotation. And this piece right here would now land on that one. The image would look the same. It would overlap it. If I want to find how many degrees that is, does anybody know what a full circle is? 360, okay. But I'm not going to go the full 360. I'm only going to go 1/8 of it. You can times it by 1/8, or you can write it as just divide by 8. You can pick however you want to type it in on your calculator. I like just dividing it by 8. So if I take the 360 and divide it by those 8 pieces, it's a rotation of 45 degrees total. Who thinks they know what the fraction would be? 5 piece would be 1/5. Good. Which means my degree, I would do 360 divided by 5. Is 72 degrees. I only go 1/5 of the 360 around. What fraction of a turn does a Ferris wheel with 10 seats need to turn in order to appear the very same as it does right now? Anybody know what the fraction would be? 10. Degree, 360 divided by 10. It's 36 degrees. Okay, one of the questions kind of got moved. It's at the bottom. I want to do it first. Kind of is hidden at the bottom. It says, how many sides does a regular polygon have that has an angle of rotation equal to 18 degrees? The rotation was 18 degrees. How many sides would there be? Yeah, what would you do?
You just do 60
Let's try it. You said 20. The answer should be 20. Okay, let's check and see. 360 divided by 18. There are 20 sides on our polygon. So we can reverse it and go back and forth by dividing. We can find the angle by dividing, or we can find the sides by dividing the 360. Did you just thought to yourself, what number would 360 need to be divided by to get the value? You said 20. That's really good. The next section is finding the angles of rotational symmetry for regular polygons, lines of symmetry, and diagonals. The first table we're going to fill in is line of symmetry. For the three-sided lines of symmetry, I'm going to draw them. There's one. That would cut it in half, right? Line of symmetry, it would fold and it would perfectly line up. 2, the triangle would fold in half and line up. 3. Okay, lines of symmetry. Where could I put a line that it would fold in half? I could put one in the middle. I could put one across this center. I heard I could do a diagonal. A diagonal would cut it in half. They would fold onto each other in this diagonal. How many places could I fold it and have symmetry? 4. All right, we have a 5-sided polygon. So I'm gonna, if I fold it here, these corners would overlap, and these ones, they would fold perfectly in half. This would fold perfectly in half. 2, 3, 4, 5. Six-sided, I could cut it in half. I could cut it in half. Cut it in half. That's only 3 so far. I could also cut it in half by going from the diagonals. 4, 5, 6. Do you notice the pattern? What is it doing?
It's just it's folding in half.
Huh?
It's how many sides it has.
So if it has 6 sides, it has 6 lines. If it has 7, it will have . And then see how it's a letter N? What would be here if I had N sides? I would have N folds, like you were saying. I would remember how, well, now I can't speak. However many sides you have is the number of lines of symmetry you'll have. Are you okay if we don't draw them in? Yeah, okay. The next one is more difficult to do. Number of diagonals. Diagonal is from corner to corner. So when I have a triangle and I try and go from corner to corner, I can't do this point to that one because it just draws the side length. There's no corners to go to, so I would have 0 diagonals. Because I can't go to these points and draw a line through it. On the square, I have 1 diagonal, 2 diagonal. Does anybody want to take a guess on how many diagonals the 5 will have? What's your guess? 0 on the 5? There are more. Yeah. How many do you want to guess?
1.
1? More than that. 5. Let's check. I'm going to show you 2 of the diagonals, and then I'll let you build more and see if you can count. From this corner, I can't go to that one, but I could go to here. That would be a diagonal. And this would be a diagonal, but I could not go to that point because it would just draw the line. So this point has 2. Then I would go here. 3, 4. Are there any other diagonals that I've missed? Here. That corner I missed. 5 diagonals. I don't want to double count any lines. Six-sided. This point can go to this diagonal, and that one. So each one should have 3. You want to be careful from the corners. If it's already drawn, don't count it again. 1. Actually, I'm going to draw a solid line. 1, 2, 3. 4, 5, 6. 7, 8. 9. And the way to double check is I look around. Does each point have 3 lines? 3, 3, 3. That one has 3. That one has 3. And that one has 3. I did not miss any.
We're sorry to interrupt.
Oh, yeah.
It's Teacher Appreciation Week. I'm around with a couple of items to give you and tell you thank you for everything you do. Teaching and working with kids and being here at Alpha. Remember, this is for you, not for student bribery.
I can't brag on it.
Well, maybe you can just.
She's a good teacher.
Good choice.
Hey,
Good
thank you.
choice. And your teacher.
I am a
chose better.
beautiful person. Thank you.
You're welcome.
It makes sense when I switched up the colors, so you can see how
You can't go back on lines.
you can't. So do you see how I started with blue? Then when I did the green, there were no lines attached to that green one. Once I got here, I couldn't draw the blue one in again because then I would be double counting it. So I only drew 2 orange. Then when I went to this point, the blue and the green had already previously been drawn. So because it already had those two lines, I only drew the one line. So my goal is not to overlap and double count on accident. So I went 1, 2, 3, which means these already had that line drawn. There were 3.
Oh, so we can like, the bottom point.
So I did 1, 2, 3 in blue.
You can't go back.
I don't want to double count on accident. So then I would do green. There were no lines on it, so I did 1, 2, 3 again, which made 6. Then I went to this point. Because the blue was drawn already, I don't count it. I would have to draw the orange, which would be 7, 8. These two were previously drawn. 9. Can't draw any, can't draw any. So 9 would be it. Have any of you noticed the pattern on the side so that when we get to these lines, they get kind of confusing? What's the pattern? What do you notice, CJ? What do you notice the pattern is as it goes from 0 to 2 to 5 to 9?
Sorry, I don't know.
It's okay. Anybody notice the pattern? Yeah, what do you notice?
First one of my two.
Up 2, up 3, up 4. Anybody want to take a guess what will go next? Up 5, up 6, up 7. So then can you fill in? What would 7 sides have for diagonals if I fill in? That was plus 2, plus 3, plus 4. What's 9 plus 5? 14. Good. 14 plus 6. And 20 plus 7. Now, usually when there's the letter N, you would fill in an equation. This type of equation you will learn in math 2. So you will learn this quarter 3 and 4. I'm not going to teach it to you now because it will confuse you. That will look weird. So for now, on your assignment, you are just going to fill in the value, not the equation. So it'll look like this on your assignment. Do you have any questions on that first page? The fractions, degrees, or finding the number of diagonals or lines of symmetry? Okay, turn the page. We will now be reflecting points and images on the coordinate plane. When I reflect, my goal is for this to be perpendicular to the line. When I reflect this point over, it should look like it's somewhere in this area, so it would be perpendicular. The points I have to choose from are this point, and this point to go to on my line. Does anybody know why I picked and highlighted those points on my solid line? Why?
Because they're like whole numbers.
Whole numbers. We like whole numbers. Now, if I take this black point and I move it to this blue one, will my line be perpendicular? Would a line drawn from here to here be perpendicular?
No.
No, that one would be wrong. What about from here to this one? Yeah, that would be perpendicular. It would make a perfect 90-degree angle. So I'm going to count 1, 2, 3 over 2. I'm going to do it again. 1, 2, 3 over 2. This would be where you would click on your homework. That's the only point you would need to graph. You do not need to click any of the blue points. The blue points are what you would visualize in your head. You would only click that point right there. The graph on the right, I'm going to highlight the whole numbers. I look for the point that would make it perpendicular to the line. I think it's the middle one again. Yep. Middle one would create a perpendicular line. So I'm going to use this blue point that I'm imagining and go down 1, 2, 3, 4, back 1. One, 2, 3, 4, back 1. This is where I would click for your homework. That would be your point once you reflect it. These tend to be the most difficult ones when your lines of reflection are diagonals. They will be the most difficult. When they are vertical or horizontal, when you reflect, you just have to count how far to the line it is. So for the U, it's 2 to my line of reflection, so I would go 2 away and click. V is 1, 2, 3, 4 away. 1, 2, 3, 4, click. T, 2 away. 1, 2, click. And then it should, to close the triangle, you'll have to double click on the point you started with to fill the line in. So you go click, 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 double click, and your image should be completed with the sides. When we reflect triangle RST, S is 1 away, 1 up, so I would go 1 up and click. T is 2, so I would go 2 and click. R is 2, 2, click. And my triangle has been reflected. It has been flipped over the line of reflection. When you have a line of reflection that goes through the image, you are going to have some points that go to the other side. It's going to look a little weird, like it's flipping around that one point. So F, or E, I apologize. E would be left one. That's where E would move. B would be 2 to the right. I would go 2 to the right. C would be 1 to the right. I would continue 1 to the right. What would happen to D if it's right on the line? Yeah, what would it do?
Wouldn't you say that?
It would stay there. Perfect. It would stay. So it is okay if your image does not move all the way over to opposite sides. It's okay if it just reflects over the line. Sometimes you'll have some that do that. If it helps, you can color it in to see the image a little better. Last reflection, we have a diagonal. I'm going to do this one a little bit differently. Do you see how it's going by one? It's hitting the corner on every one. You can count corners, and it's going to look weird, but I'm going to try and show you and see if it makes sense. So if I go along the diagonal, I would have to go 1, 2, 3 to get to my reflective line, the line of reflection, which means I would then have to go 3 corners again. 1, 2, 3. That is where I would place the letter E. Does that make sense to go on corners? Yeah? That's the way I personally like to count. You could count how far up and over it would be. Now, when I move F, I want you to notice as I go along my diagonal here, I would go 1, 2, 3 and a half. I'm going to do it again. Ready? 1, diagonal, 2, 3, half. You see how it's only half to get to here? So then I would go half, 1, 2, 3. C would be 1, 2, 3, 4 away. 1, 2, 3, 4 away. D is a half one again. If you want to imagine drawing a line, it's 1, 2, 3 and a half movements. So I would go a half, 1, 2, 3, and place the D. And it has been reflected over our line.